There's a factory outside Beijing that wasn't supposed to exist. 3 years ago, the land was empty. Today, it's producing one electric vehicle every 76 seconds. Not prototype vehicles, not test units, fully operational road-legal cars with a power output that rivals anything coming out of Stuttgart or Palo Alto. The company behind it has never built a car before. They've built smartphones, scooters, rice cookers, but never a car. And yet, in the time it took traditional automakers to finalize a single design committee meeting, Xiaomi erected a manufacturing facility that operates with the precision of a Swiss watch factory and the speed of a tech campus on launch day. The vehicle rolling off those lines is the SU7. And if you've heard anything about it, you've probably heard the numbers. 0 to 60 in 2.78 seconds. 664 horsepower in the base model. Over 800 in the Ultra. A drag coefficient that makes it one of the most aerodynamic sedans ever built. These are impressive figures, but they're not the story. The story is what happened when Xiaomi's engineers took this car to the frozen lakes of Inner Mongolia and discovered something they weren't looking for: electric vehicles and snow. Don't traditionally mix well. The weight distribution is wrong. The torque delivery is too immediate. The thermal management systems struggle in sub-zero temperatures. Tesla owners in Norway have documented this for years. So have Porsche taken drivers in Canada. It's a known limitation, an accepted compromise. But Xiaomi's team didn't accept it. They built the SU7 specifically to drift on ice, not as a party trick, not for a viral video, because solving the physics of controlled oversteer in an EV requires solving problems that affect every other aspect of how the car behaves. When you watch footage of the SU7 snowdrifting, you're watching something that shouldn't work. The car weighs over 2 tons. Most of that weight sits low in the battery pack. This should make it stable, planted, resistant to rotation. And yet, the SU7 rotates on command, holds angles, transitions smoothly. It behaves less like an electric sedan and more like a rear-wheel drive sports car from the analog era. The question isn't how they made it look good on camera. The question is how they made it physically possible. The answer starts with a decision that happened in 2021, before the factory existed, before the car had a name. Xiaomi's chief engineer, a man who spent 15 years at BMW's M division, proposed something the executive team initially rejected: a tri-motor layout. Not dual motor, which was already expensive and complex. 3 motors. 1 up front, 2 in the rear, each independently controlled. Each capable of delivering or absorbing torque in millisecond increments. The computational load alone was staggering. The cost per unit made the finance team wince. But the engineer insisted, because he understood something that most EV manufacturers had missed. Electric motors respond faster than human reflexes, faster than hydraulic systems, faster than mechanical differentials. This creates a problem. In traditional cars, there's lag, slop, mechanical delay between input and output. Drivers subconsciously account for this. They anticipate, they lead their inputs. But in an EV, the response is instantaneous. An instantaneous response in a 2-ton object creates instability. It creates a car that's fast in a straight line but nervous everywhere else. The solution isn't more power, it's more control, more granularity, and that requires more motors. The tri-motor system in the SU7 doesn't just split power front to rear. It actively manages yaw, pitch, and roll in real time. On ice, where traction is a suggestion rather than a guarantee, this system becomes a physics negotiation tool. The front motor pulls, the rear motors push, but not equally. One might be delivering 80% torque, while the other delivers 40. And these ratios shift hundreds of times per second, based on data from accelerometers, gyroscopes, and tire sensors. The car is essentially flying the driver through the corner, stabilizing what should be unstable, making the impossible feel natural. But this created another problem: heat. 3 motors generate 3 times the thermal load. Batteries hate cold and hate heat even more. Push them too hard in sub-zero temperatures, and they crack. Let them get too hot, and they degrade. Xiaomi needed a thermal architecture that could keep motors cool and batteries warm simultaneously. In an environment where the outside air was -20 Celsius, the solution they developed isn't in the brochures. It's not a selling point most buyers will ever consciously appreciate. But it's the reason the SU7 can do what it does. They've built a liquid cooling system with independent loops. One for the motors, one for the battery, one for the inverter. These loops don't just circulate coolant, they actively transfer heat between systems based on demand. When the motors are working hard, excess heat gets routed to the battery pack, keeping it in optimal operating range. When the car is idle in freezing conditions, the system draws stored thermal energy from the battery to pre-warm the motors before launch. It's a closed-loop thermal exchange that turns waste heat into a resource. And it was designed entirely in-house because no supplier offered anything close. This is where the factory comes back into focus. Because designing a system like this is one thing, manufacturing it at scale is another. Xiaomi didn't hire a traditional automotive supply chain. They couldn't. No Tier 1 supplier wanted to tool up for a thermal system with 12 interconnected heat exchangers and variable flow pumps controlled by dedicated silicon. So Xiaomi built the components themselves. They installed automated welding systems that can join aluminum coolant channels with tolerances measured in microns. They developed quality control protocols using machine vision and AI that inspect every joint, every seal, every connection. The factory doesn't just assemble cars, it validates them at a molecular level. And this is where the story stops being about a car and starts being about something larger. Xiaomi didn't enter the automotive industry to make a slightly better Tesla. They entered because they saw an industry trapped in its own assumptions. An industry that still thinks in terms of model years and refresh cycles and incremental improvements. Xiaomi thinks in product generations. They think in software updates and vertical integration and iteration speed. The SU7 isn't a finished product. It's version 1, and version 2 is already being tested. The snow drifting wasn't a demonstration of what the SU7 can do. It was a stress test of the control algorithms that will define the next generation. Every drift, every slide, every correction generated data, terabytes of it. That data is feeding back into simulations running on Xiaomi's cloud infrastructure, simulations that are refining the torque vectoring logic, the thermal management strategies, the predictive traction models. The car learns from its own limit behavior. And when those learnings are validated, they'll be pushed to every SU7 on the road via over-the-air update. The car you buy today will be measurably better 6 months from now. Not because of new hardware, because the software governing that hardware will have evolved. This terrifies traditional automakers, because they can't compete on this axis. Their development cycles are too long, their supplier relationships too rigid, their software teams too siloed from their hardware engineers. Xiaomi has no such barriers. The team that designed the motor controller sits 20 meters from the team writing the traction control code. They eat lunch together. They argue in real time. When a problem emerges, it gets solved in days, not months. This is the advantage of being a tech company building cars rather than a car company adopting tech. But there's a tension here that Xiaomi hasn't fully resolved. The SU7 is fast. It's technologically sophisticated. It's impressively engineered. But it's also a first attempt. The interior materials don't quite match the German competition. The ride quality is firmer than some buyers expect. The software interface, while advanced, occasionally feels like it's trying too hard. These aren't fatal flaws. They're the signature of a first-generation product from a company still learning what matters. And here's the uncomfortable question. How much does it matter? Because the buyers lining up for the SU7 aren't cross-shopping it against a BMW or a Mercedes. They're comparing it to a Tesla Model S, and in that comparison, the SU7 wins on almost every objective metric. It's faster. It's cheaper. It has more range. The build quality is arguably better. And it comes from a brand that Chinese consumers already trust for delivering high-tech products that work. The SU7 sold out its first year of production in 18 minutes, not 18 hours, 18 minutes. Xiaomi had to pause orders because the factory, despite its speed, couldn't keep up with demand. This raises a possibility that Western automotive journalists are uncomfortable discussing. What if the SU7 isn't an outlier? What if it's the template? What if the future of the automotive industry looks less like Detroit or Munich and more like Shenzhen? What if cars become consumer electronics with wheels, developed on 18-month cycles, updated continuously, and sold direct to consumers through online channels? The implications are staggering. And they extend far beyond one Chinese tech company building one electric sedan. The SU7 drifting on snow is a beautiful image. It suggests freedom, control, mastery over physics. But the deeper truth is more unsettling.